In this video, we're going to sum up everything that we've done so far involving our scientific notation. We've converted numbers into scientific notation and back. And what we're going to look at here is calculations that involve scientific notation. In terms of the National 5 exams, they don't tend to just ask you to convert into or reverse the process. What they tend to ask you to do is they give it in context and they say, right, how do you perform the calculation? Now, by now we should be able to read a word problem and work out whether it's asking you to add, subtract, multiply or divide. I'm just going to go over the basics as to how to actually perform those calculations. Okay, so what happens if we've got 2 times 10 to the power of 7 times 3 times 10 to the power of 4? So we know already that this is a 2 with 7 zeros afterwards, this is a 3 with 4 zeros afterwards. We could convert it back into a whole number, but you know, we kind of try to avoid having to do that. What we can do, however, because everything is just timesing each other, what I can think of is this is just 2 times 3, first of all, followed by times 10 to the power of 7 and times 10 to the power of 4. And I can use rules of indices that we looked at in the previous playlist on YouTube. We should be able to operate this without too much bother. So 2 times 3 we know is 6, and times 10 to the power of, well, we've got times 10 to the power of 7 times 10 to the power of 4. Now this is just rule 1 of indices. If I've got two bases multiplying each other, I can just add their powers together. So this is still 6 times 10 to the power of, well, 7 plus 4 is 11. So 2 times 10 to the power of 7 times 3 times 10 to the power of 4 is 6 times 10 to the power of 11. That seems easy enough. Let's just try another one then. If we've got 3 times 10 to the 9 times 4 times 10 to the 3, 3 times 4 we know is 12. We've got times 10 to the power of 9 and times 10 to the power of 3. Now, there's a reason I've not gathered these together straight away. We have an issue. We have to remember from lesson 1 on scientific notation, we cannot have a number that's greater than 10 when we're dealing with scientific notation. So what we have to do is convert this back. Now this is just 12, so that decimal point must be at the end. What I'm going to do is I'm going to move this decimal point one place to the left to create a number that lies between 1 and 10. So I've got 1.2 times 10 to the power of 1. So this 12 has turned into this bit here. I still have the times 10 to the power of 9 and the times 10 to the power of 3 to deal with as well. But now this is back in scientific notation, I can simply add the powers together again. So this is just going to be 1.2 times 10 to the power of 1 plus 9 is 10, plus 3 is 13. Okay? Our final one's just going to use divide. Same general idea. We can still use our rules of indices with this. So we've got 4.8 times 10 to the power of 7 divided by 1.6 times 10 to the power of 3. I'd be tempted to write this as a fraction. So we've got 4.8 times 10 to the power of 7 over 1.6 times 10 to the power of 3. It might even be expressed in this format rather than as a lengthy expression like this. Now all we have to do is deal with the numerical bits first of all. 4.8 divided by 1.6 is 3. And because I'm dividing two bases, I just subtract the powers. So 10 to the power of 7 minus 3 is 4. There you have it. Try some extra examples for yourself, guys.